Tell us your name and tell us about your project.
My name is Andrew Crumlin, and our experiment took place during a total solar eclipse, which happened at the same time the Sun crossed the Hydas star cluster. Because of the configuration of the Sun, Moon, and star cluster, the light from the stars will have to go around the Sun's gravitational field on the way to Earth. The idea is the light would bend as it travels to Earth. Although it's impossible to see the light bending with the human eye on a normal day, the solar eclipse darkened the sky enough for me and my team to take measurements.
What were you guys trying to do or find?
Well, in 1915, Einstein published his theory of general relativity. The theory was based on the theory of special relativity, which stated that the laws of physics are the same for all non-accelerating observers. The general theory of special relativity stated that massive objects can cause distortions in spacetime, which is felt as gravity. At the time, Einstein's theory had one massive flaw. Newton's theories disagreed with him. Our experiment's goal was to see whose theory was correct, Newton or Einstein. The big difference is that Einstein predicted that the light would bend almost double of what Newton predicted. Our experiment showed that Einstein was correct, and that made Einstein a celebrity overnight.
Where did the project or experiment occur?
There's actually two places the experiment occurred. One group of astronomers, including Arthur Eddington, went to Principe, a small island off the coast of Africa. As well, a second group of astronomers, including myself, went to Sombra, Brazil.
What other significant events were happening around the world at this time?
Well, World War I ended about a year before we conducted the experiment. The Treaty of Versailles was signed a month after we did the experiment, and Gandhi began his protest 1 month before our experiment started.
Who else was involved in the project?
Well, Sir Frank Dyson contributed to the project a lot. Actually, really the project was his whole idea. He came up with it in 1917. Eddington was the one that really led the project, though, and he measured the initial position of the stars during the months of January and February before our experiment took place.
Go. What was your role in the project?
My big role was to participate in the Brazil expedition. The part of the Brazil experiment was to fail-safe, just in case if Eddington's group could not make accurate observations of the eclipse because of the weather.
What impact did your project have on the physics community?
Well, the experiment was the first experimental test of Einstein's theories. Not only that, but the light-bending property we discovered is now known as gravitational lensing. This is a massively important field in astrophysics, and physicists are now using this to deepen their understanding of dark matter and the expansion of the universe.
What did you do after this experiment?
Well, one of my many accomplishments was I figured out that the Ford 1928 3 was identical as two other comets seen in 1978 and 1818, which were believed to be different. They have a rotational period about 28 years. I was also elected to be president of the Royal Astronomical Society and served until 1931.